Hello students, welcome to ConceptUm. Today we discuss about centers in a triangle, that is centroid, incenter, orthocenter and circumcenter. Before going to discuss about these centers, we have to know about what is median, what is internal angle bisector, what is altitude, what is perpendicular bisector. First we discuss about median. We take it a triangle, consider a triangle. Say ABC is a triangle here. Now to draw medians, we should mark midpoints of the sides. So for that we have to measure the side BC, and from that we can find out the midpoint of it. And what we have to do is, next we have to join these 2 points. Say this is D, we have to join these 2 points, and again here also we have to find out the midpoint, and we just name it as E, and one more midpoint for the side AB. Let that be F. Now here AD is called median. Similarly, in this triangle we can draw another 2 medians like B and CF also. Here one surprising thing is the median CF is also passes through the point where these 2 medians were intersect. So we'll get median, third median like this. So here all these 3 medians are passing through the same point, hence they are called concurrent lines. And in the next video we will see why they are concurrent. Now here one more thing I want to tell you is, and this point is called as centroid, and it is represented with the letter G. And here one more thing is there, this centroid divides the median in the ratio of 2:1. AG is to GD is equal to 2:1. Similarly, all the medians will intersect in the same ratio. Means CG is to GF is equal to 2:1, and BG is to G is also 2:1. The length of the part from the center to the centroid will be more than the length of the remaining part. So that is about median. Now come to internal angle bisector. Now take a triangle. Let us say this is IJK. Now here take the angles. Here one more angle, and here another angle. Now what we have to draw is, you have to draw the internal angles bisector. How to draw internal angle bisector? We can measure this angle, and with the help of protractor we can intersect and draw. Otherwise with the circular also you can draw internal angle bisectors by taking some radius, and with the center at the one of the vertex you have to draw the arcs. Here again the arcs will intersect the sides by taking these sides as centers, and with the same radius you have to draw one arc here and shift the needle of the circular and put it here and intersect that. Now join these 2 points, you will get a line like this. This line will intersect this angle here. So similarly we can draw one more internal angle bisector. And here the third internal angle bisector will also pass us through the same point where these two previous internal angle bisectors met. So that is a great thing, and that point is called as in center, and it is represented with the letter I. So that is in center, represented with the letter I. Now here from I to the sides, just draw perpendiculars, and surprisingly all these lengths are equal. Say LMN, these are foot of the perpendiculars. Here we can observe that IL is equal to IM is equal to IN. Now with the center I and with this radius we can draw a circle, and this circle touches all the sides internally, and this circle is called as in circle, and this radius is called as in radius, and this is represented with the letter R. Now take the orthocenter. Orthocenter here let's take one triangle. Say this is PQR. Now to get orthocenter we have to draw altitudes of the sides. How to draw altitudes? The altitude means it is the line perpendicular drawn from the vertex to the opposite side, like this. And here one more. This is another altitude, and this is the third altitude. Here also surprisingly, the third altitude passing through the point where the previous two altitudes met. Say CAT. These are the foots of the perpendiculars. So this is called orthocenter. Orthocenter. With the help of set square also we can draw altitudes. The altitude means the height of the triangle. So here this is called orthocenter. Orthocenter, represented with the letter O. Now the last, the circumcenter. To draw circumcenter we have to take a triangle LMN. Now for the sides we have to draw perpendicular bisectors. The perpendicular bisector means it bisects the side perpendicularly. With the help of circular we can draw, otherwise take a midpoint and draw a line perpendicularly. With the help of a circular means take the center M and take the radius as more than half of it, draw an arc here, and with the same radius shift the center to N and intersect those two arcs. You will get 2 points here, join those 2 points, you will get a perpendicular bisector. So similarly do the same thing for the another two sides. Here also the great surprise is that those three those three perpendicular bisectors passes through the same point. That point is known as the circumcenter. Here the circumcenter the circumcenter is equidistant from all the three vertices. That is a great point we can observe. SM is equal to SN is equal to SL. Why it is happening we will discuss in another video. Now with the help of this phenomenon we can take SS center and by taking these lengths as radius we can draw a circle. This circle passes through all the three vertices, so that we will get a circle like this. This circle is called as circumcircle, and this radius is known as circumradius, capital R. So this is the thing we are observing in CENTROID, and in-center and orthocenter and circumcenter. Thank you for watching my video. Thank you very much.